irrational numbers. So we should be, guys, shh. We should be in our definitions. Lots of definitions here. So, what we've pretty much covered all your math life is rational numbers. We've dealt with fractions, we've dealt with decimals, we have dealt with positives, negatives, we have dealt with repeating decimals, we've dealt with perfect squares, right? All these things here. But this still leaves a subsection of numbers that we have never really talked about, the irrational numbers. So what is an irrational number? And it can be defined a handful of ways, but basically there's two things that need to happen here to be an irrational number. It's a non-terminating decimal, basically a decimal that goes on forever and ever and ever and ever and ever, but it also can't repeat. That is one certainty you can represent an irrational number. If we go back to what a rational number is, just I'm guessing, anybody remember? I would be almost certain you have no idea how we define rational numbers, but rational numbers can be written as fractions. That's the number one criteria. If I can write it in fraction form, which is 2.3 repeating, it is a rational number. If I can write it as a fraction, because all repeating decimals can be turned into fractions, you're going to learn how to do that next chapter. Complex. But that's the difference. So you could then assume and say accurately, I can't write irrational numbers in fraction form. Technically, yes, that is correct. So we'll see how that is. So we go through and kind of, the book has all these different examples. So here we go. I'm going to rattle some off, and you guys can tell me rational or irrational why. 6/7. Rational or irrational?
Rational. Because it's in a fraction. Yeah, look at number 9. Look at number 9. In the homework.
In the homework?
In the homework, look at number 9.
Oh, look at that.
6/7.
That's good.
That's beautiful.
Look at that one.
Let's refrain.
7th grade, sorry to interrupt you.
That's
See?
beautiful.
Look at that
Zoom
homework.
it in, zoom it in, zoom it in.
Number 9.
Right. Okay, well, anyway.
That's beautiful.
That definitely was worthy of stopping. Okay. The fraction, 6/7, rational, irrational, why? I really hope you can get it. Any one of the three of you can answer the question.
Rational, we already answered
Why?
it. We already answered it.
Right, because it's in fraction form, right? B, the square root of 8. So if you take your calculator and I punch in the square root of 8, this is what I get. So this is going to lead us to, back up here. See, I'm making a third dot here, right? Non-perfect square roots. So 2-4, you covered perfect squares, right? Or 2-3, I guess I should say, right? You just took a quiz on it. You all did great. I can pass it back. I got it over there. And your test.
Did we actually?
You really did. So you saw the perfect squares. I'm certain in the video we went through them. 1, 4, 9, 16, 25, 36, right? 49, the square roots. They're perfect squares. Those are rational numbers. But all the other ones, such as the square root of 5, the square root of 8, the square root of 11, the square root of 19, anything that's not a perfect square root, are irrational. They are always irrational, non-perfect squares. So that basically means they don't ever end. There's no repeating pattern to any of them. It doesn't matter what number you pick. 13, if I push 13 We understand the calculator is only limited by the space of the screen. This is not necessarily the end of the answer. It is not. It goes on forever, but there's no pattern here. I can't ever draw a bar over any of these numbers to show that the pattern's repeating. If it doesn't repeat, if it doesn't terminate, it's irrational.
For one like 12, would we do 3.14 or just have
Oh, we're getting there, Sam. I got up through K here to go through with you. C, this one. Rational or irrational?
rational?
Rational. Repeating decimals are rational.
3/10. Or no, never mind.
1/3. It would be this one. Rational or irrational?
Rational.
Rational, right. It's a terminating decimal. Positive and negative has no bearing on it, but it's a terminating decimal. That's the part that we're cared about here. They got the
Irrational.
I'm not right.
Doesn't matter.
this is irrational. Now, I agree that there's a pattern of some sort going on here, like we're 1, 2, 3, 4, but I can't represent that with a line. It doesn't repeat. I mean, it's a pattern, but it's not a repeating pattern. If it was 0, 1, 0, 1, 0, that's a repeating pattern. That would be rational. But this, of course, this is irrational. This does not repeat, nor does it end. These 3 dots you see here, right? That means it just goes on forever and ever and ever, right? It just goes on. It doesn't mean it ends. F, wow, this is a long one here. 1, 2, 1, 2, 2, 2, 1, 2, 2, 2, 2. Rational or irrational?
Irrational because it keeps the 2s keep getting more.
This is also irrational. It's the same thing as E. There's a pattern kind of going on here, but that is not, it does not repeat. It just,
Oh, can we go to notes now?
oh.
Okay.
All right, what about this one?
Comma 16.
The opposite of the square root of 16/100ths.
Oh. That's rational because it's a terminating decimal.
Right. This ultimately just turns into this. When I clean it up a little bit, that is rational. Right, that's 16 is a perfect square. 1, 4, 9, 16, 25. Perfect squares are always rational. It's the imperfect squares that are irrational. I don't know how many. Let's try this one here. A couple more. What's that? Rational or irrational?
Oh, it's rational because it's a fraction.
Yeah. It's just a division problem. All I'm saying is this. That'll give me a real number, right? All right. 3 more. This one. I. Rational or irrational?
Imperfect square.
That's exactly right. It's not a perfect square. All non-perfect squares are always irrational. Okay, what about this one? Root 12 over root 16.
Irrational because it's. Oh wait, no, rational because it's over a fraction. It'd be over 4.
What do you think?
I think it's
Rational.
Rational? I do agree that this can be turned into 4,
Yeah, but then that top one.
but this is irrational. I cannot divide an irrational number into a rational number. This is irrational because of this. I can't, this is 4, that is rational, but I can't divide this into that because this never ends. Now, if I punched into my calculator though, again, you'd see it'll spit back. It's not that I can't do it per se, but once again, I'll get some irrational answer in return. This is, again, a non-repeating, non-terminating decimal type answer. It's, once again, taking this as far as it can, doing the calculations as far as it can, and representing it as far as it can, but it is a whole bunch of irrational stuff going on here. Last one. Rational or irrational?
Rational.
Yeah, they're both perfect squares. Just 3 over 2. It's just 1 and 1/2. That is certainly a rational thing here. How much do we have left here? You just want to finish it in the notes, the vocab, or do you want to switch over to notes? Whatever your preference is at this point here. Big thing I need you to do, because what you can see, 1 through 24 here, classify as rational or irrational. That's what we've been up to. Pi. All right, so here we go. Fourth dot, pi. There it is, fourth dot. Irrational number. Pi is irrational. Pi is a non-repeating, non-terminating decimal. If I punch it into my calculator, once again, I get a representation, but this is not where it ends. This is the first 10 digits or so, pi. But pi is irrational. And of course, pi has a lot of usage. We've seen it in geometry for certain. Whenever circles are around, pi is not far behind, or anything with curves. But we use pi, of course. We'll talk about that. But going through, I think the classifying, let's just move down to this part. So use a calculator. Find a rational approximate to the given value. I'll create a couple here. So for whatever reason, these are always very hard for a lot of people, and I never can really figure out why that is. But for whatever reason, there's just some people that just never understand what's going on with these questions here. You don't get a lot of them. I mean, you only got 28, and that's it. Yet you will see it on your quiz and test, and for whatever reason, this is a thorn in the side of 8th graders. So pay attention. So what it's saying here, the opposite of the square root of 34 to the nearest thousandth. What does that mean I need to do? Okay, I take 34. I push my square root button. I see 5 point blah, blah, blah. It says to the nearest thousandth. How many decimal spots is that?
3.
So 1, 2, 3. There I am. So am I rounding up or down?
Up.
Up. So what should my answer be?
-5 and 831.
Yeah, he said.
There's the answer right there.
I don't
That's
understand
that's
that.
the answer. I don't know. I get all sorts of. I get people can't round. People can't figure out the decimal spot. It's a world of errors. I don't understand. As I said, maybe. So if I said, what about the square root of 72 to the nearest hundredth? Well, what do you think that's going to be? The square root of 72 to the nearest hundredth.
$8.485.
Yeah, that's what I got. So I just punched in the square root, but to the hundredth, of course, would be 2 decimals.
8.49.
8.49. Right? Hundredth, 2 decimal, thousandth, 3 decimal. They kind of move it around on you. Okay, try this one. I'm getting tired of writing this part. Nearest thousandth. The square root of 7 over 3 to the nearest thousandth.
And then 10,000? Or no, just
1,000.
0.882.
That's what I got. You got that? Yeah, it's gone poorly for many students. So, yeah, all I need to do, did you get it, Colin?
No.
I take so it's 2 things. So on top, I got the square root of 7, so I push my 7, I get my square root of 7 there, right? What do I do with that? Divide it by 3.
Oh, I
Divide
see
by
that.
3.
Not be difficult with the calculators.
Right.
I just realized I just didn't.
All right, one more. The square root of 11 over 6. Thousandth. We'll move on. Square root 11 over 6 to the nearest tenth.
0.553.
Take 11 and square root it. There's the square root of 11. And then I just push divide by 6. 0.553. How'd that go, Colin? 33 says this. What's that to the nearest thousandths?
Oh.
So I'll let you try it for a second there.
I think I understand it, bro.
Anybody have an answer?
Not yet. One.
Sounds about right, Faith? Yep.
Yeah.
Wait, I want to do
So how'd you solve it?
You do 19 divided by 11.
19 divided by 11 is that. Square root it. There's my answer right there.
Yeah.
So do the division first.
Oh, I didn't
19
do
divided
that.
by 11, because basically I'm saying the square root of this. It's a repeating decimal, so it's rational. Repeating decimal inside the box here. Rational number. So that's why all rational number, and then just square root that.
Gotcha.
Right?
I didn't do that.
Good with that here. This last part here, find one rational, one irrational number between each pair of numbers. You can, all you need to do is just pick, there's endless answers here. So for 35, it says, name one rational and one irrational number between each pair of numbers. So I said between 3 and 4. Looking for two answers from you. One, a rational number. What's a rational number between 3 and 4?
3.5.
What?
3.5.
3.5. I mean, anything. A decimal, a repeating decimal, a terminating decimal, a fraction. All of these things are rational numbers. Now, the harder question. What's an irrational number between 3 and 4? There's actually one that's really easy.
3.1234123247821.
See, that's a difficult way of representing it. What would be better?
Oh, square root 3.5.
Square root, not 3.5, but what's the perfect square that gives me a answer of
9.
3? So the square root of 9 is that. What about 4?
16.
16. So if I said, give me an irrational number between 3 and 4, you could say root. Got all this space here between 3 and 4, between the square root of 9 and the square root of 16. So what would be an irrational number between 3 and 4?
Square root 12.
Square root 12. Square root 10. Square root anything between 10 and 15. Root 15, right. Yeah, these are all, because if I go to my calculator, push in the 12, the square root button, well, that's between 3 and 4, right? That's root 12. 15, well, that's between 3 and 4, right? That's root 15, 14. Well, that's between 3 and 4, right? So when you're finding the irrational number, the strategy is think of the perfect squares, right? And then pick a square root between them for your irrational number part. Easy enough?
Yes.
Try 39. So they say, what is a rational number and an irrational number between the square root of 48 and the square root of 51?
Oh, yeah,
Square root 59.
Between
Or,
48 and
49,
51.
I meant 49. No, not 49. 49 doesn't work.
Yes, it
50.
does. Well, what happens with the square root of 49?
7.
So I could say that. Or I could just make up any number. I could, right? Or right. But what would be an irrational number? I really see one choice. And,
50.
right. Probably root 50 is what I would pick for that one. Right? Easy enough? I can't really think of much more about this. Tomorrow's lesson's a little, we'll do some math. We'll be building I'll do it with you. It's probably the trickiest lesson of the chapter. 210's a little tricky too, but 2.6 is a little tricky. So if you can build the trees or understand the trees, that will be a great benefit to you tomorrow. Will help.
What does the Pythagorean theorem have to do with like